Hey guys, so we're gonna go through some factoring review stuff that you should learn in grade 10, but I have a feeling it might be a little fuzzy since you did that. So what I'd like you guys to do is just make notes like a traditional classroom. Um, I've started to write down common, like this first heading is common factors, and this is what we're gonna do. We're gonna factor out or divide by our common factor, and I'll just put it down an example. So pause the video wherever you need to though to catch up to where I'm at. Don't feel like you need to be rushed here, right? So get this written down, and then write down. So then write down this. So 15w to the 4 plus 5w squared minus 25w to the 3. So this common factor way of factoring is just we're going to take out what we can, and what I mean by taking out is we're going to divide by whatever's common to this one, and this one. So in this case, what you're going to do first is look at the numbers. So 15, 5, and 25. Well, what's common to those I can see, I could divide all of those by 5. So my first factor is going to be 5. I'm going to factor out of 5, you would say. So 5. Then my next step is I'm going to look at the W's. So I'm going to say, okay, what's the lowest power that I have? 4, 2, or 3? Well, 2, right? So at least a 2 can come, or sorry, at minimum. Sorry, I misspoke again. Um, the most you can take out is w squared, right? You couldn't take out w to the 3 because this one doesn't have w to the 3. So we're going to take out w squared. Now the next step is you're going to start a bracket, and we're going to write what we have left now. So after we divided out 5 from 15, so we went 15 divided by the 5 we took out, we have 3 there. So I'm just looking at this one right now. Okay, we had w to the 4. We factored out or divided out w2. We have only 2 w's left. We have w squared left there. Okay, and then you say plus. And now I look at this one and say, okay, we factored out a 5 already. So 5 divided by the 5 I took out, well, that's just 1. So you can write a 1 there. The w squared, I took that whole w squared out, but don't think that I subtracted it out. Some people might think, well, I don't have a w or a 5 there anymore, so I have a 0. That's not right. We divided those things out. So we divided out, so we're left with 1. So, yep, so that's that term turns into a 1. And then minus, now looking at this one, 25 divided by the 5 we took out, we still have a 5 in there. We took out 2 w's, we have 1 w left. So this is just 5w. And then close your bracket, and that's it. That's our common factors that we were talking about. Okay, let's do another example here. Let's do, I'll just write it all down and then you guys can catch up. Okay, so let's factor out this mess. It looks really confusing, right? But it's not as bad as you might think. So if we're looking at this, we're first step, like we said before, is I'm going to look at the numbers. So I'm going to look at 36, 60, and 84. Is there anything I could divide out of each of those? Well, one thing I know, I could divide out 2 for sure, but is there anything bigger than that? If I only divided out a 2, then I wouldn't have the lowest or the biggest number that I could possibly take out. I want to take out the biggest one. So if you look at this though, you can take out a 12. 12 goes into each of those. So my first one is going to be 12. Okay, now I'm going to look at my x's. I got x squared, I got x cubed, and I've got x. Remember, that's x to the 1, really. Uh, so x to the 1, that's it. That's all we can take out, right? That's the lowest power of x that we have. So I'm going to say 12x. And now I move on to the y. I'm going to say, okay, what's the lowest y I can take out? Well, that's this one, right? Y to the 1. So that's all I can take out. Now I start my bracket, and now I'm just going to write down what I have left. Okay, so 36 divided by the 12 I took out, well, that's 3. X divided by the x I took out, I've just only got 1 x left. I had 4 y's, you could think about it. I took one of those y's out, or I divided it out. I only have 3 y's left. I say 3 y's, I mean like y times y times y. Hopefully you don't get confused by that. Okay, now plus, now I'm looking at this term. So 60 divided by 12 is 5. X cubed, I took out 1x, so I only have x squared now. Y, I took out that whole y, so that's gone now. There's no y left at all. So now we just move on to the next term. So now minus, looking at this one now, 84 divided by 12 is 7. I took out an x, so I took out this whole x, so it's gone. Looking at the y now, I took out a y, so I only have y squared left now. And then close the bracket, and that's it. So hopefully, like, it's not as bad as it looks. I know this looks like a whole big mess, but hopefully not as bad as you were thinking. Okay, moving on. New concept here. We're going to be dealing with difference of squares. Okay, so what we're going to do, I'm going to actually go backwards here first. So an example of a difference of squares, first off, though, would be something like 4x squared minus 9. That's what we're talking about. This is a difference of squared. But to show you how you can get something that looks like this, let's kind of go in reverse. So let's say that we had something like 2x plus 3. And then remember from last unit we were talking about conjugate pairs? So what if we had 2x minus 3? And I say, okay, let's multiply these together. So if we do that, so we got to go the FOIL, right? That one times that one, that times that, that times that, and that times that. So that becomes 4x squared, and then minus 6x plus 6x minus 9. And what happens is our middle terms, this one and this one, cancel. Negative 6x plus 6x, they're gone. And what we end up with is 4x squared minus 9. This is what's called a difference of squares. And the reason why it's called a difference of squares is because, well, if you think about it, this one's a perfect square, 4, right? 2 times 2 is 4. This is a perfect square, x squared comes from x and x times x. And then 9 is a perfect square. And we're subtracting them. That's why it's called a difference of squares. All right. So now let's go backwards from that. So that's how we got that. That was just multiplying binomials. Now what we're going to do is I'm going to take that exact same difference of squares, so minus 9. And if we were going to factor this, what we mean is I want to put it back into something that looks like this. Well, difference of squares is kind of a handy one because those two middle terms canceled. So what we can do is whenever you come across something like this, we're going to start a bracket. We're going to put bracket, bracket. We're just going to start with that. We're going to have two factors. Now what's going to happen is you just need to take the square root of 4 and x squared. So that would be 2 and x. And then take the square root of the second one. So 9. That's going to be 3, right? Whenever you have something like this where you've got two perfect squares and perfect squares on this side as well, it's always going to look like this. And then on this side, you're also going to have 2x and a 3. And then the kind of handy little trick here is it's always just going to be a positive and a negative. And then you're done. That's it. So as long as the hardest part I've found with students in this is recognizing this when they see it. So you just need to kind of have your eye open for seeing okay, perfect square, a minus sign, and then another perfect square. And then you can kind of do this little trick. Okay, so let's do another example here to make sure that you know what I'm talking about. So let's look at this one. I know it looks kind of confusing again, but it's the same kind of concept. So like I said before, as soon as you come across this and you realize, aha, perfect square, minus, so a difference, and then perfect square, perfect square. All you got to do now is start your bracket. So bracket, bracket, bracket. And then what we're going to do is look at these ones. Say, okay, well, the square root of 16, that's 4. The square root of x to the 4 is x squared. And then one's going to be minus, one's going to be plus. So I'm just going to minus for the first one. And then I'm going to look at this and say, okay, 64, the square root of 64 is 8. And now the square root of y squared is just y. And now I've got the same thing over here. It's also going to be 4x squared, but the only difference is it's going to be plus 8y. I guess that's not a difference. That's an adding. Sorry, that was a bad math joke. Okay. Okay, let's do one more. I'm going to make this one a little bit tougher. So I'm just going to pop it up here, and you can pause it and write it down too. So it's going to be... So you might look at this one and be like, oh no, fractions. I hate fractions. It's not too bad. Again, we're going to follow the same process. So what we're going to do again is open up our bracket. So bracket, bracket, like that. And now I can recognize that, well, 9 is a perfect square, 49 is a perfect square, x squared, no, they're all perfect squares. So I'm just going to kind of keep it looking the same kind of way. And I'm going to go, okay, well, the square root of 9 is 3. And then over. The square root of 49 is 7. And then the square root of x is just x. And that's it. So then that, and then minus, I'll make this one minus. It could have been plus for this one, doesn't matter, but minus. And now square root of 25 is 5. Square root of 81 is 9. And now I need the exact same thing that I have here. I just need to put it over here, but with a plus sign. So 3 over 7 x plus 5 over 9. And that's it. So not too bad. The fractions didn't make anything that much harder. You just need to recognize if they're perfect squares. That's the key there. All right, let's do one last one for this, just because I want to make sure this is also something that students forget to do. The first thing we want to do when we're factoring any of these binomials, or what we're going to be trinomials here in a bit, is you want to check if there's a common factor first. So that's that first thing that we did up at the top here, right? Taking out the common factor. We want to see if that's possible. Sorry. So I'm going to look at both these terms and I say, okay, is there anything common to both of these? Well, W's and Y's, W, Y's, and Z's, no, they're not in both of those, right? But X's are. I can factor out an X out of both of these. So I'm going to go X and then start a bracket. And then what I have left in this first term is just W squared, Y squared, minus. Now I took out an X, so I only have X squared and Z squared. So that's step number one, and that made all of a sudden everything easier, because now what I can do is see, okay, they're all squared terms. Everything in there is all squared, and there's a difference. So the next thing I'm going to do is just leave that X out there, and I'm going to start a bracket, have another bracket like that. And now what I'm going to do is just take the square root of pretty much all this stuff. So that'll just be W, Y, minus X, Z, or Z. What would they say Z? That was weird. Okay, and then what we have on this side is W, Y, plus X, Z. And that's it. Then you're done. So big thing though, make sure to look for that common factor first, because it makes everything a lot easier. Okay, so I'm going to leave that video there, and I'm going to pick up with trinomials in the next video, just to keep it kind of its own thing that you can refer back to. So that's going to be it for that one.